Ducks behind us. We got ducks behind us.
It's a duck. You know, one with the duck now.
Yeah.
Become the duck.
Become the duck.
You are the duck.
We are the ducks. The mighty ducks.
The D4.
T4. How'd that, what was their theme song?
The Queen, we are the champions.
Oh, okay.
Yeah.
Yeah.
We could do quack.
Quack. Quack. Quack.
So, today we got the chance to interview Dr. Cheryl Keller Capone. She is a research scientist, Penn State professor. She got her PhD up there as well. She's also a part-time personal trainer because she had such an amazing journey with the things that she's doing. She's working with genomes right now.
Genomes?
It's like, call genome. I feel like it's like something you can call out, like a African-American fraternity.
Who's...
You know, like with
like a frat, like a step.
Yeah. Like genome.
Who's down to splice some DNA today? She's somebody who blends neuroscience, microbiology, genomes, the study of genetics, with strength training.
Yep.
Right.
Yep.
She's a huge proponent of physical therapy, strength training, and
the complete package. I had a couple aha moments. I think one of the big ones to me was just to hear this brilliant woman, this woman who, when you go look at some of the stuff that she is doing, she can talk. She could talk over your head without even knowing she's doing it, right? If she wanted to. And here's this woman that's brilliant, and then she's a scientist. She does her research. She does her homework. She tries to figure it out, and she can't figure it out. She tries to articulate what's the matter with her, and then she goes through a lifetime. It almost seems like it's like 20.
She's the best patient that anybody could ask for because she did so much research into her own pain and injuries, like she said. She studied pain science.
Yeah, and she's still, this might not be the right wording, but she's still falling victim to the things that plague everyday people when it comes to pain and recovery and things like that. She sees this person that doesn't work out, and it just goes to show you that, number one, those people out there, that you're not alone. That hey, look, but it also goes to show you that she's a success story, that you're not alone, but guess what? There is an answer. It's there somewhere. You just got to just go find the right person for you. Oh, you know what we didn't get to tell them about? We didn't get to tell them about how we learned that turtles are evil.
Turtles are bastards.
They'll do anything.
You'll hear, so two things. You're gonna hear about how flies are really horny and turtles are really evil.
And that's really the very end of the podcast. You get to learn natural selection is the only thing that matters.
And how she taught that important lesson to her son, which that's my favorite part of the episode, because we get the trademark Dimir Jones, who's your favorite duck question, and then we just fell into, this is how I teach my son how cruel the world can be.
How real the world
can be.
I made up a word.
Yeah?
Future. Fictionary. So, a little bit of everything.
Making up a word when you're interviewing a PhD. That's a quality interviewing. We're talking to the most educated person on the planet. And we're like, so.
And then it could be an actual duck or a fictionary duck. As I said it, I was like, no one picked up on it.
Did you say fictionary?
I was like, no, oh, come on, Jared. It's probably best though that you put it out into the world so people realize that at least 1/3 of the duck legs know what they're talking about.
No, you were leading the way on the charge. You're the original astrophysicist, man.
Fictionary.
You're
the jar.
You're the Bill Nye of physiotherapy.
No, God.
All right, man.
All right.
You good?
Yeah. Let's pack up shop. Thank you guys.
Enjoy the show.
Enjoy it. Thank you. Gonna get my face ripped off by a duck.
Broken up music. We like this style.
It's kind of one of those things. It's like the duck. You know, you see a duck in the water, right? The duck looks like it's cool, but the duck's freaking working hard under the water. Wow, working hard. That's how our place is. We look cool, but we're working hard.
And thank you so much again. Is it Dr. Keller Capone, correct? That's how you pronounce your...
Yes, Dr. Keller Capone. Actually, it's interesting because I kind of use Keller at work, and when I'm on campus at Penn State and scientific meetings, I just introduce myself as Dr. Keller because I got my PhD under that name and all my publications were under that name. And then when I got married, I added Capone on, and then it gets kind of confusing, really. But I decided once I went to social media, I just added them both and hope for the best.
And then Capone is such a historic name as well.
Yes, absolutely. Well, it's interesting too, because with Keller, I went from kind of Helen Keller jokes, growing up, and then I go to the Capone jokes. So really, there's no peace there.
You get your revenge there on the second name.
That's true. Very true.
So just to switch gears a little bit and begin the conversation on why we are here, do you mind talking briefly about why you chose grad school in science, since you have a clear passion for other fields of medicine, including physical therapy and fitness?
Mm-hmm. Yeah, sure. So I went to a small liberal arts school in New Jersey for college, and I was a biology major. And it was definitely a broad definition of biology. We did ecology, I did anatomy and physiology, genetics, and I really wasn't sure what I wanted to do. And I considered grad school, I considered going to medical school, and I did consider going to physical therapy because I had actually been to physical therapy a couple of times before I even got to college. And so in my senior year, I still was undecided. I hadn't really applied for anything, but I did take the GREs, which you need for grad school entrance, and I took the MCATs for medical school. Mm-hmm. And then I took a job, and I sort of put it off, and I said, I'm going to work for a year and see if I can learn more about myself and what I wanted to do. And I took a job working for a cardiologist in the Princeton area, and he did primarily clinical research trials for cardiovascular-based diseases and so forth. And he would see some patients in between trials, but that was the main thing he did. And it was a small office, and I got the experience of interacting with patients. And I even got, they taught me a few things. I did set up some EKGs and other fun stuff. But I felt that, I think at the time, I was young, 22, just out of college, and I felt at the time that I was trying to be honest with myself, and that I was kind of uncomfortable with or nervous about whether or not I could do it, whether or not I would be able to help people. And I think that that's probably not uncommon, in those choosing medicine. You want to help people, but you have some self-doubt. Can I do this? And so I think I went, for me, what I would just consider the safe route, and went to graduate school, in which case I could still be involved in the science of medicine, but, remove myself from interacting with patients. And it's not, now as I'm older and I'm in my 40s, I think that I would be very comfortable, and I feel like I have a lot of compassion, but I think that it made me nervous at the time. And so, that's why I wound up going to graduate school. I wasn't even really sure what I wanted to do in graduate school, actually. And I applied to a variety of places and wound up out here at Penn State. And admittedly, at the beginning was kind of difficult. I didn't really have any undergraduate research experience. I had some lab work, but just part of courses. I didn't actually work in anyone's lab. I didn't even really know what research was about. I thought, boy, I'm kidding myself here. What am I doing here? Maybe I should have went to medical school or done something else. And, it took me a while it took me 6 months or so, I felt, to kind of catch up to where my peers were at, many of whom had a lot of research experience already. Eventually I kind of got into a groove, and I wound up in the lab that I worked on muscle development. And it was using Drosophila or fruit flies as a model system, and flies do have muscles. But it was And people are always, what, they have muscles? But, they fly and they move and they crawl. And we worked on embryonic muscle development. So looking at tiny little fly embryos. And they do have muscles. And I got to learn about muscle, not only muscle structure, but muscle development. And over the course of the embryonic period of development. And we took a genetics approach. And this was very, really interesting to me. And it made for some good conversation, out at the bar sometime too, because when you're setting up crosses for flies, and you need females that have been unmated, and we call them virgins. So I'm like, oh, I got to run the lab. I have to collect virgins. So we made for a good joke here and there, right?
Oh, so many fly virgins.
Yes.
Oh yeah, ton of flies. You have plenty of fly virgins. So, and you'd be running out there, late at night because you don't want them to mate and collecting your virgins. No. So. It gets to be kind of funny. So
you got to get a handle on those flies.
Exactly. So I did that. Yeah, so that went well. And around that time, and most in academia, most people do not stay at the institution where they got their PhD, and it's actually sort of looked down upon, and you're encouraged to move on and go to another institution. But, And in fact, as a rule, at least in life sciences, I feel that it not only hinders your own development as a scientist, but also you're not as able to contribute, I guess, as much because you're not getting as broad of a background and experience. But as we all know, life takes hold, and I met my husband just when I was finishing up. And so I stayed here for a postdoc position, and I changed fields at that point and did mice. Went to mice. I went from flies to mice. I'm changing model systems, and I worked on GABA receptors. Yeah, well, of course. I worked on GABA receptors, which are responsible for the majority of inhibitory neurotransmission in the central nervous system. So this is where my experience with neuroscience comes in. I worked in that field for about 4 years, and which was really interesting. And actually, especially since there's a very close relationship, certainly between the nervous system and the musculoskeletal system. Yeah, I really enjoyed kind of being able to blend some of that information, and so I felt like I got a lot out of both of those. And then I did a few other things. And when I finished my postdoc here, I actually went and worked for a local company who did mitochondrial DNA forensics for about a year. And that was pretty exciting. We had to handle cases, and a lot of it was cold cases in which they were trying to exonerate, individuals, and sometimes we did, and sometimes the data supported that, and sometimes the data didn't. And
wow.
some of the cases were higher, I don't say more popular. That's not what I mean to say, but I had heard of the case, if you will, and
right.
And that to actually kind of feel like you're having a more personal link or an potential impact either way, either good or bad on a person's life, whether they're going to stay in jail or get out was kind of bothersome in a way. I mean, good as long as you got the right answer, right?
Right. That's amazing.
But yeah. But I think what I got out of that too is a good, strong feel for quality control and attention to detail. I mean, you really, you have to be very, very careful because you're handling evidence, and it's someone's life you're talking about. And, not somebody's life in the medical way, but in somebody's life in their freedom, and which is certainly an important thing. But so I worked there for about a year, and then a position opened back up at the university. And eventually I went back and then I landed up in a genomics lab. So that's what sort of brought me to where my current position is. And along the way, I also did a little bit of teaching. I co-taught a sophomore level anatomy and physiology course. And then I taught a couple semesters of a sophomore level molecular biology course. I've kind of done a variety of things, but now here I am in genomics. You guys have some genomics questions?
First off, you are by far the most interesting guest that we will ever have on this podcast.
Well, thank you.
Yeah.
I don't even know where to begin.
Yeah.
Like, genomics is one field that we have a bunch of questions with, but after hearing your whole backstory, I have no idea where to begin. Tyler, you?
I do kind of want to come back to the genomics. I mean, you know what, we can start with it. So just to the layman's, if you could give a few sentences to explain, what genomics are, I don't know the.
Sure. Yeah, absolutely.
And kind of,
I think there's
what is happening with it right now.
Okay.
Genomics
I think
is so
that there's
hot
also
right
some confusion. Yeah, it is very hot, I think. And there's also some confusion between genetics and genomics and epigenetics and what do those terms mean? And when we're talking about genetics, a lot of times it's referring to, a specific gene or variations of one gene, and whether you have a mutation in this gene, and you're kind of using a gene-centric approach, if you will, right? So everything is really more focused on what happens if you have a mutation in this gene. Does it cause an increased function of the protein, or does it cause a decrease in function? And how does that affect if you knock the gene out, if you remove function? What happens to the organism, or what kind of disease does it cause? And so it's very focusing on a more narrow view. And then when you're talking about genomics, you're actually looking at the genome, the whole genome in the organism. So you're doing the analysis on a much broader scale. You tend to look for patterns, and it's not that you're ignoring one gene or another, but and most people will focus on a particular system, but you're trying to look at patterns throughout the whole organism in terms of what's going on with their genes. In general, how are genes turned on? How are genes turned off? And what happens as a result of that? So, for example, if you're looking at if you have a model where you have a mutation in one particular gene, and what you might do is then look at sort of a wild type or a version where so let's take mouse, for example, where the gene is perfectly functional. It's a wild type mouse. And you might look at all the genes that are expressed and what levels they're expressed at. And then you would also look at the mouse which has the mutation in this gene of interest. And then you'll look at all the genes that are expressed in that mouse. And you look at the differences. So yes, you have a gene that you're interested in, but what is the effect of that mutation through the entire mouse? Okay, so we're trying to look at more global patterns. And you can do this by looking at sort of gene expression, like I was suggesting, or you might look at where different proteins, where they bind or where they attach to different parts in the genome, and how does that happen? So it's more of a larger analysis. And so it's definitely big data kind of thing. It requires, the analyses require more bioinformatics approach, more computation. And I'm definitely a bench scientist. So I do a lot of the upfront lab work, DNA sequencing. And then I should say that the genomics, the way we ask and answer questions in the field of genomics is primarily through assays that involve DNA sequencing. And that's really sort of what I really love about it. I think it's fun. It's definitely, there's a lot of attention to detail. But there's also a bit of an art, like almost anything else, right? You learn the techniques, but then you got to kind of have a little bit of a tweak to kind of come out and just know exactly the slight modifications that might be needed in order to, produce high quality, reproducible data.
I can only imagine the attention to detail that's needed.
Yeah, well, I'm a perfectionist, I will admit, and anybody who knows me personally knows that to be true. So I guess I wound up in the right field because, science is definitely about, finding the right answers and attention to detail and reproducibility. And actually, that's a big problem in general, or a perceived problem, I guess, in science today is reproducibility of results. and how well they apply more globally or more broadly to different populations. So just to give another example now, I was using mice, but one of the projects that we are working on, we're working with a group down in Virginia in Dr. Tom Logren's lab at University of Virginia, and they study LGL leukemia, which is large granulocytic leukemia. And so, we're using a genomics approach to try and gain insight into the processes that are involved in why this form of leukemia occurs and how that happens. And it's interesting, this is a particularly interesting form of leukemia because the cell type that's involved, these lymphocytes, large granulocytic lymphocytes, the cell type is actually a normal population. So in normal individuals, in non-disease, they're present, but in those with leukemia, LGL leukemia, that population of cells expands greatly, at the expense of other cells. So, we want to know is, why is that happening? And we can use genomics and to learn more about not only what happens in normal state, but also in the disease state. So that there's several types of projects in that respect of how we can use genomics.
Awesome.
It's so funny because after hearing your story and a little bit more about you, seeing things like while I was watching your Turkish get up and how precise and perfect it is, it just fits your character just so fittingly. Watching you exercise, like, man, this person just doesn't move an inch. Just very attention to detail.
I am, and I'm really a stickler too for sort of quality movement and getting it right. So
there is a distinct correlation between the form of somebody's Turkish get-up and how well they can splice DNA, right? That's been proven.
Yeah. Yes. Absolutely. I don't know, although it might be correlation, but we can't say causation, right?
Damn it, science.
There you go.
All right. So I got kind of a follow-up one. I'm so interested in how attention to detail you are and how you stay focused and how you really seem like the type of person that reads the entire article, right? And in a society where, they say ADHD is running rampant, people don't read the entire article. You just look at the headline.
And even if you read the entire article, it could be a fake news article, and haven't learned anything.
Mm-hmm.
Could be. But how does someone, what are some things in your mind, and how does someone, be persistent and read entire articles and things like that? I know that's kind of a crazy question, but really, is there any strategy to keep that attention to detail?
That's a good question. I think that reading articles, there's certainly, whether you're talking about, science, more scientific, like hardcore, jargony scientific articles versus, an article that's more directed toward a layperson, if you will. And I think that, scientists are definitely, I say guilty of using a lot of jargon, because a lot of times to really communicate, exact details of our work, we do use a lot of jargon, and that definitely reduces the ability of the public to, really grasp, the importance of research. And I think that there's a kind of becoming more awareness of that, and a increase or encouragement of scientists to improve their science communication and make it more relatable to the public. And I think that's important. So, and even really, if I'm reading an article outside of my field, sometimes I have trouble getting through it. I mean, it's not uncommon to run across so much jargon. If I'm reading something, if I'm reading an article and the jargon is too much, it does become, kind of tedious, and it's hard to really focus and get something out of it. But that's actually a big step, in graduate school, and they sort of force you into it, in your field when you're preparing. Yeah, right. When you're preparing, you just have to keep reading and reading and reading and reading. And eventually, it sort of starts to sink in. And then one day you might have a thought, that might be because of A, B, or C. So really, I think that is, yeah. I mean, as long as you're making sure to read quality sources, if you're getting your information from, fake news, if it's a source you're not familiar with, most likely you should be a little skeptical, right?
Right.
But most high quality journals, it's not like you can really say believe everything you read, because I think that there's a healthy amount of skepticism is important, because you want to make sure that the methodology is solid, and whether they are just overhyping the result. So I try to always read with a healthy amount of skepticism. But you also need to be open-minded and be open to evidence and be willing to change, your opinion. And I think that that's sort of the hallmark or important both for any scientist and for any clinician, right? Is to read and try to be open to new ideas, but yet be open, but with a little skepticism, right? So don't just jump on the bandwagon, but you don't want to exclude potentially new and helpful information. But honestly, really, if you're really just trying to gain knowledge in your field, you kind of just got to suck it up and keep reading.
Yeah.
Eventually, it sort of sinks in. I actually felt that when, and I guess we could go into this in a little bit, but when I was kind of starting to deal with all these injuries and chronic pain, I wound up just reading a ton of pain science literature and other physical therapy articles, and I felt like I was doing another postdoc with the amount I was reading and trying to get through these articles. But eventually it kind of crystallizes if you have some patience. So
yeah, so
it's time, it's effort.
Yeah, so to stay on that subject, you mind talking a little bit about that journey from pretty much going to a patient to becoming a strength coach, and sort of kind of get into that wellness aspect and what we know you as on Instagram as doing those Turkish get-ups and just killing it in that field. Do you mind talking about that journey a little bit?
Perfect Turkish get-ups.
Sure.
Mm-hmm. Yes.
Thank you. Well, no one does a perfect Turkish get-up, but I always strive, right? So it's interesting, and I do actually have a fairly long history with physical therapy and pain. I'm hypermobile, and I tend to have always sort of lacked stability, and even as a child, I was very injury prone and always falling over myself, and tripping over my own feet and so forth. I could never hang from the monkey bars, and I had a kind of a neck injury and when I was about 10, 11, and it was just something where I turned my head and then I couldn't turn it back. And it was sharp and it was burning and but this, I'm in my 40s, so this happened in the early 80s. I know I'm dating myself. Okay. But there was no, people didn't take their kids to physical therapy back then. My mom was, oh, you'll be fine.
Yeah.
Here, have a cookie, whatever.
Yeah.
And, so after about 2 weeks, sure, the pain, went away or went mostly away, but I really never regained full range of motion. And my entire life, I've always preferred to look to the left a little slightly because it's more comfortable for me. And I've always, when I go to talks or am I sitting with someone, I would prefer to interact with someone on my left because I didn't have as much range of motion on my right. And also then I when I was about 13 and I was taking karate class and nobody paid attention to form back then or safety. It was just do it, right? And we were doing, as part of a conditioning, I was doing bilateral leg raises, and I did not have the strength, the abdominal control, the core control to keep my lower back on the ground. So I just did these leg raises up and down, and it was just all lumbar extension, And eventually, a lot of repetitive lumbar extension, uncontrolled. And I developed extension-based back pain, and again, it's just really sharp pain, and I again, complained to my mom, and don't get me wrong, I'm not criticizing my mom, but it was one of these things. Eventually, she took me to the doctor after a couple of weeks, and I felt like I could barely sit and barely walk, and they're like, "Oh, there's nothing wrong with you." Okay, was fine. But yet I continued to have pain for pretty much most of my life. But I just kept, eventually you kind of just deal with it. Well, having, occasional neck pain, occasional back pain, but it didn't hold me back in the sense of, I just kept going. I started running. I ran. I was a collegiate runner. I did cross country. I did track. Did have pain from time to time. I had a number of injuries, potential stress fracture, and some foot pain. I always had a, classic quote unquote runner's knee. And my IT band, and I'm putting all these invisible quotes, which you can't see because I recognize that these are just more sort of symptom descriptions, not a real diagnosis.
Right.
But,
We know.
Yeah. So I do recognize that, but at the time was my perception. But then when I was dealing with a number of injuries, and I in hindsight, probably I really just needed to gain more stability and control over my body, being hypermobile. But after I had a baby, my son was born in 2005, and after a couple of years went by, I never stopped running. After college, though, I stopped running real competitively, would just do a few local races. But then after my son was born, when I started running again, I was like, I really want to kind of get back into racing more. And so I stopped. Again, I was having more knee pain, and many people had put me in years before. People had put me in motion control shoes with orthotics, and it was probably one of the worst things you could do for somebody who's hypermobile, right? But I didn't know any better at the time. And they eventually, when I went to get shoes, talked me out of the running shoe store, talked me into stopping wearing my orthotics, and just so okay. And I did, and I was reading, and I'm like, okay, transition to less supportive footwear and go slowly. And I tried taking about 5 months to slowly transition into more neutral shoe. But, I started having a lot of foot pain and some arch pain in both feet. And it was not, so physically I was going, kind of getting worse, but my running at the time was actually getting better. I was having more pain, but I was running really well. And I was a D3 runner, and I, whether or not I could have made it at a Division I school, I don't know. But, for D3, I could run a 5K for cross country in maybe mid to low 18 minutes or so. So pretty decent. Yeah. So, but then I decided that, so once I started running again, so I'm running, I'm like, I think I can be even faster. So then I thought, I'm going to start chasing my college times. Big mistake. Yeah. So I completely, after having a baby, and I didn't do any now there's all these, pelvic health and postpartum, people who are doing all physical therapy for postpartum moms. I didn't do any of that, and I didn't know any better. And I had a lot of weak mobility and stability issues. But I thought, I really want to break 19 minutes again for a 5K. This was my goal. So again, this is my first mistake, putting fitness before health, right? And eventually, so I went to speed things up. That's sort of how I kind of had an injury history to begin with. But I started went to see for some arch pain, and no, there's really nothing wrong. I'm like, well, okay. So I kept going, and eventually wound up with a post-tib injury on my left foot, and then I had to wear the boot, and I went to physical therapy, and it was just morely focused on my foot, and it really, in the end, wasn't really any better. And they said, well, it's just pain, and you got, the tendon has to get stronger. You got to just keep getting it stronger. And I'm like, okay. So, and I get that, and I know that is true, and that you do need to load it. If you have an injury and you rehab it, and you got to load it and make it stronger. I get that, but there was enough things that had accumulated in my own body that obviously that was not going to be enough for me. Nothing else was addressed. My breathing was not even remotely mentioned, and my hip mobility was poor. But really, the physical therapy was just focusing on my foot, rehabbing the post-tib, and so I started running more, and I'm like, okay. And they're like, well, you just got to keep going. And I'm like, well, okay. So I feel like I'm following medical advice here.
Yeah.
And I just kept getting worse, you know, and I would see someone else, and I make an appointment with the orthopedist, and, you know, so then they referred me to somebody, and I did like 3 rounds of physical therapy, and it was starting to get very frustrating. You know, I felt that things were getting worse, not better. And then, but I kept running because people told me that I should just keep going, you know, and I'm not one to sit around and not do it, especially if I have medical clearance to do so. So, and then in around 2011 or so, I was, this foot pain, both bilateral foot pain and tingling in my feet was getting, a little bit more frequent. And then I had weeding in my backyard, and I pulled a weed, and it was more of a rotational sort of injury, not a lumbar like flexion extension, but like a rowing motion, pulling out a weed. And I felt just kind of weird after that. And I pulled out really hard, and I was like, ooh, like as if something, you know, wasn't quite right. And then the next day I woke up with constant tingling through my whole foot and leg. And it was just, and so of course I'm back to the doctor, back to physical therapy, and you know, things are getting worse and worse and worse. And I started having, and no one could really give me any advice. And then we go with the MRIs, and I have a spondylolisthesis of L4 and L5, and you have a disc bulge and all that stuff where they tell you, you know, that I realize now, right? You're not supposed to be imaging patients left and right. And It just makes people more upset and more fear, right? But I didn't know any of this really at the time. And you know, everyone who I saw was basically, you know, giving me a different opinion. And I felt that, you know, for the most part, providers would focus on one thing or another, you know, without sort of looking at the whole picture and really backing up. And the problem is that I kind of felt like as I was seeing someone new, you know, it was so overwhelming to really go through my entire history. But I felt that my nervous system was just getting so jacked up, you know, and I'm turning my head to the right, and I'm getting severe vertigo, and I was having high blood pressure reading when I never in my life had high blood pressure. And you know, I felt that I was really at a super low point. You know, I was having trouble making dinner for my family, and you know, I eventually had to just stop. I'm still trying to run, right? And stupidly, but I felt like it was my only sort of outlet, something I loved, and I sort of defined myself as a runner. Mm-hmm. But eventually I did have to stop, and I ran into a local physical therapist who I had known previously, and he had just opened up a cash-based PT office, and I was like, please, can you help me? You know, I really need help. And I was a mess, and then admit I'm sure I was a very difficult patient. At that point, though, I felt, you know, years had gone by, and I'm barely functioning. And he was great, and he's very compassionate. And he said, look, you know, this is a complex case, but, you know, we just have to take our time, and we need to just slowly work through things. And he didn't promise me he was going to fix me, and he didn't. And I said, well, what's wrong with me? And he was honest. And he said, you know, I don't know. There's probably multiple things going on, but we just have to work our way through. And I felt like, thank you. You know, as a patient, I mean, I want a diagnosis, but at the same time, I respected the fact that he said that he really didn't know exactly, you know, what we were going to do, but we were going to we're going to try to calm the nervous system. We were going to try to, you know, work to improve strength, improve posture, reduce asymmetry, and slowly peel away the layers of the onion.